Alright, we're going to install Arch Linux today. So this guide is meant to be a little faster and easier to follow than the official documentation. We're going to put everything you need here, like how to set up the network, bootloader, and some other things that might be left out on that one page. They do include everything if you want to follow the links and poke around on their website, but if you want everything in one spot, this guide will give it to you. If you look at the page in the description of look at the link in the description of the video, you'll find a page with all the instructions all in one place. And we're going to cover all of that in this video. Alright, so here you see a VM. We're going to boot up Arch Linux. We're going to boot up the live install disk. We have the grub menu. Just select the first option. And there we go. We have our root prompt. So I didn't actually cover downloading the media. I should talk about that a little bit first. So if you look over here, this is actually the article that's going to be linked in the in the description of the video. Yeah, so we have a nice little link here. The video is pretty much going to be embedded right here, and you can go to the download site like this. You can use like BitTorrent, or you can use the HTTP downloads. BitTorrent's a lot of people recommend it, but it basically froze halfway through for me, and just the regular HTTP download is pretty fast, and it only took a few minutes. Depends on your internet connection and how you like doing things. So once you download it, you can verify the GNU-PG signature, pretty much just like this. I probably should do that, but we can come back to that later. As a note, you use the signature from archlinux.org, not from any of the other mirrors, because they could have theoretically been tampered with. If you want to create a USB install disk, you can. We're not doing that because we're just installing on a VM. But if you wanted to, you could just run dd, and these are pretty much common parameters. Like you generally want to see status equals progress. You want to sync it when you're done. BS equals 4 megs. Specify your input ISO and your output device, assuming like SDC is your USB drive. You're going to want to make sure you have the correct device before you do that. And this will work for Linux. We don't have the setup for Windows on here, but you can find that pretty easily. We're just not covering that. So this is if you're already a Linux user, we have the instructions for you here. So boot from your install media, which we've done. It's going to give you Nano, VI, and VIM. You can use the elinks. You have basically a text-based browser called elinks that you can use if you want to. And if you actually want to view the install guide from within the install, like say if this is your only computer and you're installing on this and you don't have a separate browser, you can actually view the official documentation from the command line here like this. And you can see you pretty much have the entire official documentation in a text document, which is pretty nice if you need it. We're not going to follow that today. We've pretty much come up with what I think is a little bit easier and more complete directions. So keyboard layout. If you wanna, you can change your keyboard layout if you want to. We're not going to do that here, but you could basically I'll show you where the layouts are. And that pretty much just shows us all the layouts that are available. If that's too much, you could like pipe that to less, and you can pretty much page through them if you want. If you did want to install something different, you'd type load keys like this, and type in the whichever one you'd want to switch to. Like for example, you could type that to get DE-Latin1. We're not going to do that. We're going to stick with the default, which is the US keyboard layout. Next thing, you want to see what your boot mode is going to be. If you're going to be using like BIOS or CSM, or if you're going to be using a UEFI. In this case, this VM, I know some hypervisors are going to have EFI. VirtualBox apparently doesn't, which is fine. We're just going to use BIOS or CSM. That's going to affect how the installation goes later on. But I'll show you how you can check which mode you're using if you're not sure. And there you can see nothing's there. I did an ls on this directory, and it doesn't exist, which means we're in BIOS mode. So if it were EFI or UEFI, you're going to see a whole bunch of files in there. And then that would pretty much just tip you off that that's the system that you're using. For network setup, by default, it's going to be, if you're on a wired network, it's going to be DHCP. So if you have a DHCP server and you're on a wired network, you're pretty much all set, which we are. So we don't really have to do anything to change it. If you do want to see how to set it up for either Wi-Fi or static IP address, I can pretty much show you the commands. I'm not going to actually run them here, but if you look at our instructions, you type. You can view your link. We'll run these: IP link and IP adder. See your device. And if you want to bring up you can pretty much copy and paste this off of the document that's linked to in the description of the video. But you can say ifconfig, device name, IP name, netmask. Put your netmask in there and up, and that'll bring your interface up with the IP address you want to assign to it. You can say route add default gateway and add your default gateway. Then just add Google's DNS servers to your etcresolve.conf. That should be enough to get you online if you're using a static IP and you have all the correct IP information. For Wi-Fi, you could say Wi-Fi-menu-o and then whatever device name that you had. We're not going to cover using that tool here. I'd have to get a laptop or something set up for that, and we're just not going to do that in this demo. So I'm going to just show you what the IP link and IP adder commands look like, and then we're just going to ping archlinux.org just to verify we have connectivity. And there we go. Looks like we're online. So next thing we're going to want to basically turn on NTP. Basically tell the time date CTL. This is just telling systemd to use NTP. This doesn't actually start the NTP daemon, as I understand it. This just tells systemd to use NTP to pull the time down from the internet. And we're going to do this during the install. basically just because it's probably just better to have the correct time. I don't know that you absolutely have to have it during install. We actually do this again after we chroot into the. You'll see how that is further on in the install, but we do it again later on the installed system to enable the just enable this again. So we're going to run this for the installer right now, and then we're going to run it again later for the installed system. So we're going to set it to true, and then we're going to check the status. And there we go. We can see the local time in UTC. You can see universal time. And yeah, we haven't set our time zone yet, but we're pulling down the time from NTP. It thinks we're in the UK, I guess. So local time is the same as the universal time, which is the same as the real-time clock time. So pretty much what our hardware thinks the time is. Which is fine. So this is all okay now, and you see NTP service is active, and real-time clock in local time zone, no. So the real-time clock is just pointing to UTC. So that's completely fine for now. Next thing, we're going to just list out our disk devices, and then we're going to start partitioning. There you can see we have 2 devices. SDA is our hard disk, and SR0 is our CD that we booted from. So that's an ISO image CD that the VM just booted off of. If you're using a USB disk, it'll be your USB disk. If you're using an actual CD, physical CD, it'll be the CD. What else? Let's try fdisk-l. All right, and here we pretty much see almost the same thing. We see dev SDA, 8 gig hard disk. That's where we're going to install our operating system. Now, the only absolutely required file systems or partitions that you have to create is a root partition, and if you're using EFI, you need a EFI boot partition also. We're not using EFI, so technically we don't need a separate boot partition. I think you used to a long time ago, but not anymore these days. Generally, you are going to use more partitions like that. Also, if you want, you can add more partitions like /var, or you can put pretty much any part of your file system on its own partition if you want. We're going to keep things simple for this guide, but one common case is to use /var, because that's where like variable size files go. That's where your log files go. Some people would like their data served up by their web server or anything else there, anything that might change in size or grow. That way, if it fills up, it's not going to fill up your root partition and take your system down or compromise system performance. And it's also easier to grow just by replacing the disk if you need to, and you don't have to take your system down for that. So these are basically what the partitions are going to look like. I basically took these tables out of the official Arch docs and modified what I said the mount point is. This is like the mount point after boot, whereas they listed the mount point where you're originally going to mount it when you first install software. You're going to mount it under /mnt and then place it there. You'll see when we continue on with the install. But basically, if you're doing BIOS MBR, a simple setup is a root partition. That's going to be Linux partition type, remainder of the disk after your swap partition. Your swap partition, you don't strictly need it, but you generally should have it. You could also use a swap file if you wanted, but in Linux, people usually just use a swap partition. The swap partition is going to be Linux swap. It's recommended to be more than 512 megs. It used to be that you would make it like double the size of however much RAM is on the system. That was a long time ago when people had a whole lot less RAM. Now, if you have like 32 gigs or 64 gigs of RAM, you're not going to double that size for your swap partition. That would just be crazy. So doubling your RAM for your swap partition isn't something you generally do anymore. Let's see, for EFI, you're generally you're gonna need a boot or EFI partition. We're not covering that today because we're doing a BIOS install, but you're gonna want to create a partition for that, and you're gonna want to create your root partition and your swap partition. So this is a common use case. The official documentation doesn't actually cover how to use Fdisk. I'm sure they have links to other documents that show you how to do that, but they don't cover that right in the documentation. And it's pretty self-explanatory. It's not like the easiest, most user-friendly tool in the world, but Fdisk is like it gives you a help command, and it pretty much tells you how to do everything you need to do. I pretty much have this little cheat sheet thing here showing what Fdisk commands you'd have to type to complete everything that I completed. And I have some screenshots on the official documentation showing you exactly what that looks like. And we're actually going to try that out now in our VM. So let's go through this right now. So start off with fdisk dev SDA. And now we're we're basically running Fdisk on the install disk that we want to install on. And we can pretty much type M, and that basically gives us all the commands that are available. Pretty much just it's help or documentation. If we want to see what partitions are there already, we can type P to print out partitions, and you can see there are no partitions. That will give you info about the disk, like basically like the disk model, the size, and the bytes and sectors, and a whole bunch of other stats, disk label type, and so on. Now, first thing we're going to do is create a new partition. We're going to keep it simple and just create two primary partitions for the root partition and the swap partition. Now, you could create extended partitions if you wanted to. If you're going to create more than 4, you're going to want at least one of them to be an extended partition so that you can create as many sub-partitions as you want. We're not doing that today. We're just keeping it simple, so we're just going to use primary partitions. So to create a partition, we're going to say N for new, and then you can choose either primary or extended. We're going to use primary, so P for primary, and then partition number 1 through 4. So primary partitions, you only get 4 of them. Extended partitions, you can create more. So we're going to make the first partition our swap partition, just because it's easier. We're going to use like the first 512 megs, and then we're going to create a root partition after that. So type number 1 for the first partition, and take the default as the starting place, which is the beginning of it. So first sector, just hit enter for that. And you can specify this in like K, megs, gigs, or whatever. You can starting sector or whatever else. All different ways to specify this, but this is the last sector. And I just specify it in based on how many megs we want it to be. So we want 512 megs. So we can say plus 512M. This is going to create a partition of 512 megs. And there we go. There's our partition. If we want to verify it, you can type P, and you can see there's a brand new partition. Now you're going to notice that it's the wrong type. We're going to have to fix that. Basically just created that by default. So it's a Linux partition. The ID is 83, so that's the type it is. So if you want to change that, you can type L, and that lists out all the different partition types. So notice this was type 80, ID is 83. Like if you look up, yeah, it doesn't show my mouse, so I can't highlight it. But ID is 83, and 83 is a Linux partition. We want it to be an 82, which would be Linux swap. So you can type T to change it, and you don't have to, it selects partition 1 because there only is one partition. Otherwise, it's going to ask you for the partition type. So it's a little easier to do this one first, the one that you're going to change. Do it first, and then whatever, you don't have to select it. It's not that it's a big deal or anything. But yeah, just type 82, just change it to swap. And there you go. Now it's Linux swap. If you want to verify that, hit P again, print out the partitions, and there we go, fixed. It's a Linux swap. Now we're going to create one more new partition, N for that. Primary partition, so P, partition number 2. And first sector is the first one available. And the last one by default is pretty much the end of the disk. So you can just hit enter again, and there you go. If you hit P, you can view your partitions, and you'll see that we have we have a Linux partition. That's going to be our root partition, and we have so that's SDA2 is going to be our root partition, which is Linux, and you can see SDA1 is our swap partition. So I am going to we're going to actually have to make this writable. So actually did that further on. Or rather, we're going to have to write these partitions. So even though we've created them, if we exit the tool, it's not going to actually write these to disk. But before we write these to disk, we're going to also want to make sure the root partition is bootable. So, so notice that boot column, none of them are bootable. So we can say A and the partition number, so 1. And that, now if we hit P again, you see, yeah, that was wrong. All right, A. Now we just removed it because we put the bootable flag on the wrong partition, which wouldn't go so well. Hit A to make another one bootable, and we can say partition number 2. And there we go. I think I actually could have picked that by default. Yeah, the default would have been 2. So if I hit enter instead of 1, that would have just given me the correct partition. So I guess that's what I get for not paying attention. So print it out, and the correct one is bootable now. So our root partition is bootable, which is important if we want the system to actually come up. And also important to remember to write out to the disk. So W to write out to the disk. And there we go. We've pretty much partitioned our disks. Next step is going to be formatting the disks. So to do that, let's see. I'm going to say mkfs ext4. So basically just like this, mkfs.ext4 dev sda2, and that's going to create a Linux extension for file system on our root partition, which is SDA2. And there we go. It partitioned it pretty quickly. Now we're going to want to create our swap partition. We already have the partition, but we're going to want to turn it into a swap drive and actually turn it on. So we're going to say mk swap and say dev sda1. And then we can say swap on dev sda1. And there we go. We have our swap drive. Do free-h, and you can verify that it's actually there. Looks like I only gave this system like 4 gigs of RAM, which is fine, I guess, for an Arch install. I'm not even going to put X Windows on in this in this video. I am going to do a tutorial on how to install X Windows in the GUI in a later video, but not in this one. So 4 gigs is overkill for this. Let's see. Next, we're going to want to mount our root partition, but we're not going to mount it over root yet because that would pretty much that's where all our system utilities are, and we still need those. So our new system, this is where our root partition will be in the future. We're going to mount it temporarily over MNT. So we're going to say mount dev SDA2 MNT. So you can see that last one on the bottom there, SDA2 MNT. That's going to be eventually, that would be on the running system after install. That's going to be mounted on root, but right now it's mounted on MNT. And that's where we're going to basically install our system onto that directory coming up in a bit. And once we've actually installed the system on that directory, we can chroot into that file system. So then it's actually going to be mounted on /root, and you'll see how we do that. So optionally, we can edit our mirror list to pick a mirror that's geographically closer to us. And this is actually going to work during the install, and it's actually going to use this as the mirror location for your package manager after installation too. So you want to make sure you get it right. It's not just for the install, but it's for after the install as well. So you can say vi etc pacman.d mirror list, and you see the first one is in France. We're in New York City right now, so we don't want to pull from France. I'm going to grab a United States kernel.org server. I'm going to hit YY to yank that, :0 to go back to the beginning of the file, and just to P to paste that right there at the beginning of the file. Escape and exit out of here. And we've just edited our mirror list file. So that's going to pull from the mirror that we want. The next thing we're going to do is actually install essential packages. So we're going to install the base package, the Linux kernel, and then some firmware for common hardware. So we do that with the pacstrap command. Now, normally when you install software, you're going to use Pacman, but when you're installing software to this specific directory before actually mounting the system, you're going to use the pacstrap command, and that's just like for installing systems. So you can say pacstrap like this, and say MNT, that's the directory you want to treat as your root directory, even though it's not yet. Say base for the base package, Linux, and then Linux dash firmware, and that's firmware for common hardware. So do the basic install. This is basically just installing the bare essentials, everything you absolutely need to get going. Yeah. Usually this is where I get up and get a cup of coffee or something, but yeah, when you actually sit here and watch it, it seems to take a little longer. It's not bad, but takes longer when you watch it. And there we go. That's it. Um, yeah, it didn't really take all that long. So that basically installed the basic core system. Um, we're not ready to reboot and have a working system yet. We still got a good ways to go. Um, Next thing we're going to do is generate the FS tab. That's your file system table. So if you're used to other Linux distros, that's going to be etc fs tab. So this is going to be based on the file systems that are currently mounted. So our current swap partition and our current root partition. It's going to read those, and it's going to read what's currently mounted, and it's going to basically write those to the FS tab for our new system. So we say gen FS tab, so generate an FS tab, -u /mnt. It's going to treat this as the root system or whatever, the root file system, even though it's mnt. Redirect that out to mnt etc fs tab. So this is going to create a new file system table. If we want to see what it did, we can say mnt etc fs tab, and there we go. Pretty small, minimal file. Not a whole lot in there. They're actually it's all comments except for 2 lines. One for your swap partition and one for your root partition. That's pretty much it. If you see some other systems like a fresh Ubuntu system or a fresh Red Hat system after install, you're going to see they have a whole bunch of different entries in here and all kinds of junk, which is they have good reasons for, and that's arguable. But this is a whole lot cleaner and more minimal. Depending on what features you add later, it might become a little bit more complicated, but yeah, this is pretty simple file system table. So the next step we've been talking about is ch rooting, and we're going to do that now. So there's a specific arch. Normally you could say ch root, and people use that in other for other things, like if you're building Linux from scratch or other in some other situations. But in this specific situation, we're going to use a command called arch chroot. And there is actually just a command called chroot. We're not using that here. We're using a special version of the command called arch chroot. And we're going to say /mnt. So the file system, our root partition, which we had already mounted on /mnt, we're going to chroot to that directory. So we're going to change that file system that's mounted on mnt, make that the root file system right now. So we're going to be operating on this file system as though we were actually working on the installed system. So chroot to mnt, and there we are. So if we cat etc instead of mnt etc fs tab, we can just cat etc fs tab. You can see that's our new file system table. Say df-h. You can see you can see our new dev SDA is mounted on root instead of the live install disk. So that's our live system. The system that we're actually going to our actual system that we're building is actually the root disk for that is actually mounted right now, so we can directly modify it any way we want. So it's a pretty simple, straightforward way of doing things, and I think it's a pretty neat way of doing things. So there are some essential packages that some are and some are not recommended by the official install. Normally you're supposed to go through separate guides showing you how to do each of these things. They're considered non-essential, but there are certain things that I think you should have on every system. So before just for basic Linux install, I think I would call them essentials. That's debatable. You may not agree with that, but I'm going to bring our guide over here. And so the first thing I'm going to run I call important or semi-critical, something I personally just think should be part of every Linux install. We're going to run Pacman Yes, and this is the command you would use to install packages on your installed system. Like after we're done installing, if you want to install additional packages, this is the command you would use, Pacman-S, and then the package name. So you can pretty much, instead of saying one package, you can just list out all the packages you want to use. So like Pacman-S man pages would install the man pages. If you want to install man pages DB, and so on. All of these, and then a slash to continue the command on a new line, another slash to continue on a new line, and so on. So yeah, man pages and man DB, you're going to need these for your man pages. So if you want to get help on any commands, you're going to need to install those. So I think that's pretty critical, and every system should have those. Like, there's no reason not to have those. You actually don't, if you follow the actual official documentation, you don't even get that in. It's really, really minimal, and you don't even get the man pages. The other thing you're going to want is DNS utils. So this gives you things like the host command. Like you won't even, without this, you won't even have the host command if you want to do like DNS lookups and stuff. ETH-tool is a good tool for testing your Ethernet hardware, so you can get stats about your interface and stuff. IPutils gives you ping and other utilities. NetTools is the old deprecated, but it gives you like ifconfig and some old network utilities that I'm a little bit more familiar with. It used to be the standard tools for Linux, but that's been replaced by IProute. That gives you some newer tools that people like to use these days. It's basically a package it's a replacement for NetTools. Honestly, I'd say you don't have to choose between one or the other. I just install both of them. It's not like you're going to bloat your system by it. None of this stuff is going to give you an even remotely bloated system. It's all just it's all basically pretty much everything on here is pretty small and minimal. So it's, adding one more package just to have it is not a big deal. And even then, we're still not adding. We're still only adding very, very few packages. If you look at the packages installed on the install CD, you have like this huge, big, like paragraph-sized list of packages. So, anyways, OpenSSH. If you want to be able to run the SSH command, which I think is pretty critical on a Linux system, you're going to want to install that. wget is good if you want to just pull a website down from the command line. It's a standard network utility. I consider it something you should just have as a network utility. USB utils, just stuff for looking at what USB devices are connected and information about them. USB mode switch is for certain devices. Will actually, on a Windows system, they would have the device driver inside the USB system, and it would get mounted as if it were like a storage device, and send the driver over to the over to the Windows system, and the Windows system would send an OK back to the device. Then it would switch over to its normal operating mode. So if you run those on Windows, obviously you're not using, or rather, if you run that on Linux, you're obviously not going to use the Windows driver. So, there will be no way to actually change the device over to its regular operating mode, and it's just going to look like a storage disk when it's some other USB device. So this software helps you manage that as though it kind of like tricks the device to think it's running on Windows. You could think of it that way. Another tool I would recommend having is TCP dump. It's good for troubleshooting networks, and I'd consider it just a standard network tool that you just should have. SmartWAN tools is just a good thing if you have a hard drive and you want to monitor this hard drive health. It's kind of a standard system utility I think you should have. Netcat is good for troubleshooting network problems. Another standard network utility I just think you should have. I might add to this list later on, but this is what I have so far. What I think is like absolutely critical. Nice to have is like Midnight Commander. I've generally never used it, except just to try it out. But it's a text-based file manager, and it's pretty nice. You may as well have it. It's a nice utility, and it's super tiny, so you may as well just install it. DOSFS tools, XFAT tools, and NTFS 3G. So that's going to help you handle all kinds of Windows formatted file systems, like SD cards and all sorts of other things that just happen to have Windows file systems. There might be some more packages that you might want, but that should be that should cover a lot of stuff. And those were 3 packages I thought were pretty nice to have if you want to just be able to plug an SD card in or a USB drive that's formatted for Windows or something and just be able to read it. If you want to be able to mount another drive that happens to be formatted for Windows, that's just it's just good to have. And part clone and is good for cloning partitions. You have parted, which is a partition manager. Same with GPT, Fdisk, and part image is just another partition. I think it does partition imaging. I haven't ever used it, but these just are good tools for dealing with disks and partitions. I feel like they're important system utilities that you should have. Not as critical as the stuff up here, though. So we're going to go ahead and install those. I can't copy and paste because I'm in a VM, and it just doesn't support copying and pasting. So I'm just going to install right here like this. I'm just basically just going to type these in. And it looks like I didn't leave a space before the slash, and it just didn't include a space at all. And there we go. Just hit yes to proceed. And there we go. We've got those. Got the first set of packages installed. We're going to do the other ones now. All right, so now that we have those installed, we're going to show you how to install Wi-Fi software. So this is what you would install if you just want support for Wi-Fi. Maybe you just want to have the packages there just in case. Maybe you're on a wired connection in your laptop. You just want it in case you're using Wi-Fi later, or maybe you did have to figure out how to get Wi-Fi working for this install, and you're now installing these packages. But either way, if you want Wi-Fi to work, this is how, these are the packages you'd want to install. All right, and I think pretty much every system should have development software. So we're going to install Pacman-S base devel. And you see this is going to include things like bin utils, bison, file, find utils, flex, gawk, GCC, pacman, grep. Wow, really grep and gzip. Yeah, those are pretty critical commands. Sed, sudo. You know what? I have not even tested to see if sed or I know sudo. You're gonna have to install that separately or get it from this command. But so I know you don't get sudo, like by default you don't get the sudo command. I did not realize you didn't get like sed and gzip. I thought those were standard utils and bin utils. I thought those came with the system. Like I thought, there's no way to not get those. But actually reading over this package list, you get a lot of. You really do need this. This isn't just. I mean, it does give you GCC and make, but it's more than just tools you need to compile things. Like if you want to be able to run the which command or unzip tar gz files, or even just grep for things, you're gonna. This will pretty much give you all of that, and those are things you kind of really need. So I'd view these as being really critical system utilities that you kind of just have to have, even if you're not compiling software. But we're by default selects all. We're going to select all, Y to proceed, and there we go. All right, so we've got those installed. Now we're going to install Vim. It turns out now that we've chrooted, I'll show you why we need this. Now you'll note that I tried running VI on a text file, like our file system table. It says VI command not found, Vim command not found, Nano command not found. So three example text editors not found. So we have no text editor now. So if we want to continue editing text files, which we do kind of need to do for the rest of the installation, we're going to need to install some text editor. And once we have our system built and we boot into our newly installed system, we're going to want a text editor. That's pretty critical. It's actually amazing that it's not in the Arch Linux base install, but that's fine that it's not. It's not a big deal. Now Vim is like improved VI, so Vim is like a drop-in replacement for VI that's just better. Some people might prefer VI. I'm not sure what the reasoning behind that is, or if there's a reason for it at all. But yeah, VIM is just better than Vim, and people use it as a replacement. A lot of Linux distros just install Vim and then link the VI command to Vim. So when you type VI, you're actually typing Vim. That's what we're going to do here. Now, there are separate packages, one for VI and one for Vim. You could install both or either. Instead of installing both, we're going to install Vim, and then we're going to create a link from the Vim command, from the VI command to Vim. So when you type VI, you're actually running Vim. So that's what we're going to do. Now, as to why we're installing VI instead of Nano or something else. I mean, Nano is great if you don't know how to use VI or you just don't like VI. It's okay if you don't like VI. I'm not going to bother to install Nano. It's worth learning VI, not necessarily because it's better. Some people might think it's better. But the reason to learn VI is because it's pretty much on every Linux or Unix system out there. There's practically every single system that exists that's Linux or Unix is going to have VI on it. so you know you're going to have it. If you log into some server that someone else set up, you're not guaranteed to have Nano. And in most cases, for most servers I've seen, they don't have Nano. Some might these days, but yeah, you're not guaranteed to have any editor except for VI. A VI is, you can usually count on it unless it's some rare weird fringe case, but VI is always there, and so it's always going to be there. You can pretty much always count on it, so it's worth learning. Whether you like it or not, you might think the whole way it's set up is stupid, but or you might love it. I've gotten used to it, and I kind of like it. Sometimes I use it in place of even graphical editors. It's not bad, but it is what it is. Whether you like it or not, it's worth learning just so you can edit files on pretty much any Linux or Unix system. So yeah, for my command line editor, I generally just stick with VI. I don't use Nano or any of the others usually. Not that I'm against them, but on the command line, I'm just going to use VI because I know it and because it works totally fine. Now, in a GUI environment, I'm going to use a bunch of other things. I use like Sublime Text, Atom Text Editor, and like gedit, Kate, and there's like a whole list of other things you would use. And those are great for a lot of different use cases. So you wouldn't want to necessarily use VI for everything, but on the command line, this is what I use. And I would recommend using it. And even if you hate VI, I would recommend, even if you do opt to install Nano, I would recommend installing VI also, just so you have it. And even if you choose not to use it on the command line, you prefer to use something else on the command line, that's completely fine. You should still learn VI just to know it, just so you can get around if you have to use it. So here goes. All right, and there we go. We created a symbolic link. So you can see the VI command actually points to the vim command. So that was pretty quick. We installed the vim package and linked it pretty quickly. Let's see if we can install Nano just to do it, just because a lot of people out there probably would want it. And there we go. That was pretty easy. You just say Pacman-S Nano if you want Nano. I generally wouldn't bother to install it, but that's a little bit more straightforward. You can see now that VI is working, or actually Vim, and it's pretty nice. It gives you syntax highlighting by default. Even in a config file, like this is not even source code. This is just your file system table, and it's good enough that it can give you some pretty nice syntax highlighting on here. This looks nice and pretty with all these colors in your file system table. But yeah, if it can do this, it'll highlight scripts for you. It'll do nice syntax highlighting. You can write your Python code, your Java code, whatever coding you want to do. I think VI is pretty great for coding. Not everybody likes it though. And a lot of people would call me crazy for saying that. So next thing you want to do is the time zone. So our system doesn't know where we are now, so I'll show you the basic syntax. Yeah, so this is the syntax. Blah blah blah. User share, zone info, region, city, etc. So yeah, we're gonna use New York, and yeah, it looks like I typoed this a little bit, so I'm gonna have to fix that. Yeah, so that was wrong of me. Don't type the command like that. Yeah, that's where I type out my instructions. I'm gonna fix that before this video actually gets published. But yeah, I'm gonna fix that in my instructions before the video is published. But yeah, don't do what I did. Make sure you link it to Etsy local time. All right, so now you can see Etsy local time points to user share zone info America New York. So now we're in the New York time zone. So now we're going to set we're going to generate our 80J time, which assumes the clock, your hardware clock is set to UTC, which it is, which we verified before. There we go. And now we're going to, remember before we ran time date CTL to turn NTP to true. We're going to do that again for our installed system. All right, so actually looks like it's set to active, so maybe we didn't need to do that again. Let's see, we can see the time zone set to UTC, which yeah, it's probably going to take effect after we restart our system. We're going to want to verify that actually. So yeah, the time zone is not reflecting what we just configured, but that's fine. We're just going to make sure it does come up with the correct time zone once we actually start our system. So we're also going to edit our Etsy locale-gen file. Then we're going to actually generate our locales. So you'd want to put whatever locale you want in here, whatever one happens to be where you are. Pick that one. We're going to choose ENUS, so we're going to show you how to do that. We're going to VI our Etsy locale.gen. And you got to type the actual correct name of the file, and now just search for the locale you want. Alright, so basically all the locales are in this file, and they're all commented out with a pound sign. So we want ENUS UTF-8 and then UTF-8. So just hit X to uncomment that, and that's pretty much all you have to do for the ENUS locale. You right quit, and there we go. Now we're going to actually run the locale gen command. And you can see it generated our locale that we selected. And now we actually have to set the language in Etsy locale.conf, which is yet another locale-related configuration file. So let's give that a shot. I guess that should pretty much be it. Now we're gonna actually edit our vconsole.conf file. We're not actually gonna make any changes in there, but if you wanted to change your key map like we looked at before, you would. So yeah, we're gonna leave that not changed and with nothing in it, and just stick with the default. That's the same file we were talking about before, back at the beginning of our installation. Actually, no, I take that back. That's not the same file we were looking at before. That was just loading keys. So before we looked at loading the keyboard layout, whereas in this case, I guess that's just I'm really not familiar with what that file is for, but we don't actually have to edit it or change anything in it, unless you do need another key map. Actually, I should take that back yet again. I do know what the file is for, but yeah, I'm not that familiar with it. But it's basically for setting the key map for your keyboard. So if you do want to, like if you were to look back at our instructions way back here at the very beginning, we talked about where did we, keyboard layout right here. So you can see the keyboard layouts, and you could run load keys, which would temporarily load a new keyboard layout for the installation. Now, if you want that to be persistent, that's what this file is down here. Yeah, so that's what your vconsole file is for here. I've never actually had to edit this and change it to something different. I've luckily for me only had to use the default ever. But if you do want to change your key map, that's where you're going to do it. And using the command above that we looked at the beginning when we first started the installation, that command will show you all the key maps that are available, and you could look them up with that and then put them inside this. You'd have to create a new file, I guess, and just put them inside here. But we're not doing that today. So network configuration, we're going to want to do a few basic things for network configuration. Like we're going to start with your host name and your Etsy hosts. Then we're going to move on to persistent network configurations. And notice there's a ton of different situations where you need the VI command. I didn't notice, I may be wrong, I might have to go back and double check, but I didn't notice them telling you to install VI during in the official Arch Linux documentation, and you kind of do need it, but not a huge big deal. And maybe I'm completely wrong. I should go back and check and see if they did actually tell you that, and I missed it. But in any case, you really do need to have VI or VIM or some editor installed. But here we're going to set our host name in the Etsy hostname file. And then we're going to configure our Etsy hosts file. This is going to be pretty generic. If you're, we'll get to the part that might change depending on whether or not you're using static or DHCP. Feel free to use tabs if you want. I'm not using tabs. It's just not how I like to do it. I have heard of like super ancient Unix systems from very long time ago that treated tabs and spaces differently and would cause problems if you use the wrong character. That's not a thing these days, but Yeah, I just prefer to use spaces for everything where it's appropriate. And I like things to line up. So this is just, and it's just white space. It doesn't matter. So this is how I'm doing things. You don't have to do things the way I am. So the first two lines, you're setting your local host. So 127.0.0.1 is the IP of your local host. That's just what that IP is designated for. So we're mapping that out to the name localhost. And then the ::1 is the equivalent IPv6 address. So the first one is IPv4, the second line is IPv6, both for your local host. Now, if you're using DHCP, you're going to want to, we're going to actually specify an entry for your host name, and you're going to also want to use your local host IP address. You're going to use 127.0.0.1 for your actual host name in this file here. But if you were using a static IP, you would use the actual IP that you're going to, the actual IP of your network interface here. And you can see some more detail on that if you look at the documentation that's linked in the description of this video. Now, we put the local host name, we put the host name twice, and the reason for that is the first one is canonical. So like arch-test1.local domain is the canonical name, and then the short name for it is just arch-test. So the order matters. The first one is the canonical name. And now this IP address right here at the beginning, you would set that to something else. Like if you're using static IP, you might set it to like 192.168.0.25, for example. For example, I'll bring the documentation over here, and notice in this little code box right here, you see this is an example of a static IP. It's a private IP, but it's a static IP that you might set if you're using a static IP address of, for example, yeah, I basically tell you everything you want to know about it right here. Static IP versus just using this if you're using DHCP. That's pretty much it for that. Let's see, if you want to do the persistent network configuration, so you could do DHCP or static IP. So both of them you're going to, now if you reboot the system as is, you are actually not going to have a network connection, because even though you have DHCP on the install disk, that does not mean you're going to have DHCP configured when you reboot the system. It's not there by default. A lot of distros will give you, will configure your NIC to DHCP by default. This one does not. It does not give you any persistent network. Your network information is not persistent at all. So on Arch Linux, you're going to have to configure it whether it's DHCP or static IP. There are a few different ways to do that. You could write a script, systemd combo, or something like that. Write a custom script that brings them up using commands, or like the commands we talked about at the beginning of the installation. So you could run your temporary commands and just place those in a script, and then start that with systemd. That's a little bit elaborate, and if you're going to go, like, it's not a standard configuration file for your network. So I feel like that's the wrong way to do things. I feel like the more correct way to do things is just to use a network manager in this case. Now, typically with other distros, I'll use their default configuration files for static IP addresses, and I basically disable the network manager. One of the first things I do is just disable the network manager and use the default configuration files for the operating system on other distros. But I mean, really all that's doing is it's going to have some script that starts up and that just looks for that location for the config file. So that's really all that's happening in other distros. Arch Linux doesn't have scripts like that built in, and it doesn't have a default location for your network config files. So you'd have to create one yourself or use the network manager. So the network manager just kind of feels like the more correct way to do things. You could come up with something custom on your own if you like, which is completely fine if you want to. So before we get into the network manager, we're going to do our etcresolve.conf. Now you might be thinking, oh, if I'm using DHCP, I'm going to get my DNS servers from my DHCP server, and you can do that if you want, but unless you set up your own DHCP server and it's exactly the way you want it to, I wouldn't trust like your internet router or anything else to give you a good DHCP server. Now, if you're in a corporate environment and this is a server, maybe you have a network team that has DHCP servers set up and you want to use like your corporate DNS server, then definitely just leave that up to DHCP. But if this is like a home system or a desktop system, then you probably just want to stick with Google's. I personally use Google's name servers. They're trustable. They're gonna like if you're a home user, you don't want to trust your ISP. You definitely don't want to use your ISP's DNS servers, ISPs, even though there's like net neutrality or there was anyways, even back when they did have that. They've been known to censor things out by just like say you're trying to get to a website and it just you can't reach it. It's because your ISP's DNS servers just return it as not existing. You switch to Google's DNS servers and it works perfectly. So generally, I'm going to recommend Google's servers. They want you to be able to reach everything. And there are other options out there too if you want trustable DNS servers. But yeah, for me, whether you're using DHCP or static IP, I'd recommend in most cases just add Google's name servers to your etcresolve.conf. We'll show you how to do that right here. The first one's their primary name server and then their secondary name server. And there we go. Yeah, let's take another look at that real quick. All right, so that first one, pretty easy to remember, all eights. That's their primary name server and then their primary public name server anyway. And 8844. You don't need that, but just in case, it's good to have two. So those are Google's DNS servers, and that's what we're going to use. Now for DHCP, so let's look at the examples from the documentation first. So DHCP, it's going to look like this. Static IP, it's the same one. You're gonna. And I should say a note on network managers. So there are multiple network managers. We chose to use systemd network D here for reasons. I think it was just the best supported. I mean, you could use others. There are advantages to others. Some of them have a GUI, like this one does not have a GUI. So if you're running a GUI system, you want to configure it from a GUI, not the command line. You might not want to use this one. This one comes with the base system, and it seems to have good options all around. So I'm going with systemd network D. And for that, we're going to use these two config files. Well, this one config file, 20 wired network under systemd network. Now you could configure this file for DHCP like this. Assuming this is your network device, make sure you use the correct device here. If your device has a different name, put in that different name. So like before, you're going to have to run IP link to see the correct network interface that you have and input it into there. Yeah, same deal here for static IP, except for static IP, you actually have to specify the address. Like for DHCP, you just say DHCP equals IPv4. Static IP, you have to say address gateway, and you can specify DNS again, which you can specify here, or you could just rely on your resolve.conf. I'm actually going to leave this, I'm going to leave these two out. So it's going to be, what I do in the video is going to be a little bit different than this documentation. Let's see, what else? Then when we actually want to do the network manager, systemctl enable systemd network D. So that's going to enable it. So that's different from starting it. That's just going to enable the service. We don't want to start it yet because we already have a network address for the installer. We're just enabling the service so that when we restart the system, the service will come up. So if it's enabled, that means anytime the system boots, this service systemd network D is going to start up, which is what we want. Now, if we ever did want to start the system manually, I commented these two out, but I just feel like they should be there for reference, even though this isn't how to use systemd reference. But yeah, if you want to start it, you can say start. If you want to check the status, you can say status. Those might come in handy for whatever case that comes up after the boot. That's up to you. Yeah, that's, if something comes up for you, then those can come in handy. There's also a stop command and a restart command and a bunch of other systemd stuff. But that's yeah, it's not something you want to run here, but that's stuff that's if you need to troubleshoot after booting, you can. Let's see. So Wi-Fi, similar. So this is the same. Yeah, we don't really cover Wi-Fi here, so there's probably more information you'll need. The official Wi-Fi document is linked here. This is the official Arch Linux Wi-Fi configuration documentation if you follow this link. But you'll notice the file we were looking at before was 20 wired network, and this one down here is 25 wireless network. So different priority. Anyways, let's configure DHCP. It would be nice to use a static IP for the demo, but we're just not doing that now, just because of how my VM is set up and how I don't have it on the same network. It's netted, so it does have DHCP, and we're just going to configure that now. If you do want static, it's really easy to use, and just use the example. Just use and modify the example that we have on our documentation. Alright, so that's pretty much it. It's pretty simple. Yeah, just specify DHCP and the interface. So ENP1S3. Now, actually, interestingly enough, I think that was the interface name the first time I ran this installation. For whatever reason, it looks like my interface is actually ENP0S3. So this is the kind of thing you want to watch out for. Don't just blindly copy the device name in there. We're actually going to really need to change that. So we're going to go back in there and change that 1 to a 0. And there we go. So Etsy systemd network 20 wired network. So that's pretty much it. That's your that will make your network configuration persistent on reboot. we're going to enable the service like we mentioned just a little bit ago. All right, so you can see it says it created a symlink, blah, 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 created symlink, blah, 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 multi-user wants systemd, etc., etc. So it's telling you the symlinks it created to actually enable this service. And so it looks like it's successful. Let's just run status just to see. Status isn't going to actually do anything. All right, so running in chroot, ignoring request status. I guess that's fair enough. So probably if we attempted to, you know what? Let's try starting it just to see what it does. You're really not. You shouldn't do this, but whatever. Let's just see how it works. So yeah, running in chroot, ignoring requests. So how about that? I had never tried that before. I figured if it did work, it would not. It would behave kind of unpredictably. But looks like if you're in chroot, you can't run these commands for systemd. Like systemd knows you're in a chroot. So for user setup, you're going to type the password command. That's going to set the root password. There we go. We've set the root password. And now we're going to add a user called user1, as I'm not creative with coming up with usernames. So this is going to be a regular user we're going to add. We're going to add user1, and we're going to add them to the groups wheel and users. Adding them to the wheel group is going to allow them to be able to su to root. They're still going to need the root password, but they'll be able to su to root. We're not going to have sudo installed by default. Actually, I think we will because we installed that devel package, but it's not going to be configured by default. It's a great thing to have if you like using it. It's a standard package, but I don't feel like it's an absolutely essential package to get your system running. I feel like that's more like a post-install sort of thing. So we're going to install sudo after the system's installed in a separate tutorial, not in this video. So no sudoing in this video, only suing directly to root, which some people would consider not as secure. That's debatable, but also it doesn't leave like an audit trail. So if you have a multi-user system, it's suboptimal, I guess. But yeah, it's not critical to get your system up and running, and I don't feel like we should have that as part of our Arch Linux install instructions. That's a little bit off topic, so that's a post-install task and a topic for another tutorial. So let's add our user. All right, so we added the user1. The default shell is going to be bin bash, which is nice because bash is a great shell. Only thing I would recommend above bash is probably the fish shell, which is a whole nother story. Also, user add dash m dash g. The G specifies group. So wheel allows you to su, and the other group, so it's two groups in a comma separated list. Users is just the regular list of all users, or all regular users anyways. So to set user one's password, you use the password command and specify the actual user. If you don't specify the user, it's presumed to be root, which if you are root, you can change it. Now, if you're root, you can also change any other user's password, so here we go. Now, you don't really have to go looking at the etc password file to get the system installed at all. That user add and password is all you really need, but I feel like we should just take a look just to see. Now, as you can see, it added that user to the end of the password file, and that's it. That's 1,000 for the UID and the group ID, home directory in the default shell you can see. So basically you can see the results of the command. Just felt like I should throw that in there. Let's look at the shadow file too. And here we can see like our encrypted passwords for our users. A lot of users don't have encrypted passwords, so you couldn't log in as them, but the root user and our user 1 do have encrypted passwords. Interesting to note, we're really getting off on a tangent here, but I actually just used the same password for root and for user 1. You wouldn't really want to do that in production, but I did here, and you'll notice that the hashes are different, and that's because they've been salted. So that's just an extra bit of information that goes into how the password's hashed, so it comes out randomly. So if two users have the same password and they look at their encrypted passwords, they won't be able to say, hey, that guy has the same password as me. So in this case, if someone called user 1 had the same password as root, you wouldn't want their hashes to look the same. Otherwise, he'd be able to say, hey, root's password is the same as mine. So that's why the hashes look different. They start with the same 3 characters, $, $6, but after that, they're different. So there are multiple options for the bootloader. 2 popular options are grub and systemd-boot. Since we are using systemd a lot, not everybody likes systemd, but yeah, we're going with that for now. You don't have to like it if you don't. Anyways, systemd. Since we are using systemd, you would think we would probably select the systemd bootloader, but we're not. We're using grub because I like grub better and it has way more features. Now, the positive side about systemd boot is that it's really simple, it's easy to manage, it's really simple and minimal, which sounds really great, and it would go, since we're using systemd anyways, we may as well use it. But grub is just so much better, and you can have like a splash screen in the background and all sorts of other options, and I just think it's better, and I understand it well enough that I think we're just going to go with grub. Yeah, I think grub is the right choice, so that's what we're going with in this guide. If you want to, their Arch Linux, their wiki has a documentation telling you how to use other bootloaders if you like. So we're going to start by installing grub, which we don't have yet. So we can say Pacman, grub, and OS Prober. We also need OS Prober. So here goes. And from now that we have the package installed, we're going to create we're going to mkdir a boot grub directory. Then we're going to create the grub config by saying grub mkconfig-o for the output, and the output file is going to be boot grub.cfg. Then so that's going to generate our grub configuration file, and then we're going to say grub install dev sda. So that is going to actually install grub over the master boot record. So when the system installs, it's gonna run whatever code is on the master boot record, which is gonna be grub. Grub is gonna boot up, and then first thing grub is gonna do is mount the root file system and look for its configuration file under boot grub. Yeah, so it used to be that grub could only manage mounting like a small boot partition, which is why you would have your boot partition separate. These days boot doesn't have to be separate. before we actually install that, let's take a look at the config file just to see what it looks like. And you can see this looks like, for as simple of a thing as it is, it's not like there are a ton of options. You just have to tell it where like your file system is, and not a whole lot else. You tell it like what kernel to run and so on. There's not a whole lot that it really needs to know. This config file is way, way, way more complicated than it needs to be. It's always been a kind of a pain working with grubs, which is something that made me think that systemd-boot might not be such a terrible thing after all. But I think the functionality of grub is worth it, even if that functionality only means a splash screen and maybe some other things that I can't think of off the top of my head. That said, I remember the days of Lilo, Linux Loader, which only works on BIOS systems and won't work on new EFI systems. That was the old way of doing things. So the grub we use today is grub 2. Before grub 2, there used to be the regular grub, and then before, the original grub, and before that there was Linux Loader. Linux Loader had a super easy, a super simple, straightforward config file, which I miss. But what are you going to do? This is how things are today. Or this is how grub is, and grub is what I've chosen to use. And there we go. That was pretty fast. We installed grub to the master boot record of dev SDA. Notice we didn't specify we did not specify a partition or anything. Just the disk itself. So another thing that we're going to want to do is install microcode. You could skip this, but you probably shouldn't. It's really fast and easy. Sometimes CPUs are buggy, and you can load microcode to fix them. This is a way to patch bugs. Sometimes it can be loaded from your BIOS, from your system board. But if your BIOS isn't up to date or doesn't have the latest fixes, you're pretty much out of luck. And there's no way you're gonna. Basically you're out of luck. You wouldn't want to count on anything like that. You're better off just loading the latest packages from the OS. So Linux actually has the ability to load microcode into your CPU, basically patching up any like say for example the recent meltdown bugs or vulnerabilities. So any new bugs with buggy CPUs can be patched, or I guess you would call it patching. But you can load microcode. And so we're going to do that by installing a package. Install the package, then we're going to run grub mkconfig-o again to write this stuff out. Once we install the packages, we just regenerate our grub file, and it'll be loaded into that. It'll be loaded into grub, and grub will then load that microcode into your CPU. So your own, depending, there's a different package for Intel and AMD. Depending on which one you have, you only need the one for your CPU. But if you're creating like a USB disk, like a live USB disk that you might want to bring around to multiple systems, or you might want to move your disk from an Intel system to an AMD system, you can just install both of them. So in this case, we're just going to install both just to do it. But you don't have to. If you're running AMD, you only need the AMD. Intel, you only need the Intel. And technically, you don't absolutely need either of them. So here goes. All right, so that's it. We pretty much installed the packages and updated. We updated the updated grub, so that's pretty much it. We're gonna restart in just a bit. Let's see here. Was that? Let's just see if that was everything. Yeah, I feel like I'm missing something. No, I think that's pretty much it. Regenerate grub to config. Grub config to activate the microphone. Code update by running. Yeah, that's pretty much all you need. So we're going to exit our chroot environment and reboot. And you're going to want to unmount the install media, which I did not do quickly enough, so I just forced unmounted it. We're at the boot screen for, this is the boot screen for the installer, so we're going to restart our VM again. So reset. There we go. Now we're going to boot off the hard disk. Now notice our grub menu is way more simple here. So like I said before, I hit this stupid pop-up, but anyways, there we go. Now we're already booted into our system. That was pretty quick, right? Booted off the hard drive, and we're already booted. Let's just log in. And there we are. We're logged in on our freshly built new system. That's how you install Arch Linux. And about grub, as I was just saying, notice the install media has that nice splash screen and stuff, whereas our install does not because we didn't configure it. But since we're using grub, we have the option to install a nice pretty looking splash screen, which I guess doesn't have that much functionality over systemd, but that's just what we did. This is our fresh system. Let's take a look over it real quick. So yeah, you'll see it says Linux Arch Test. That's our host name, so on and so forth. We can see like our kernel version and so on. If you want just your kernel version, you can say like -r, but yeah, this is so it's specifically an Arch kernel. You'll see that in the it's also in the uname-a output. Let's look at like our basic info, like our CPU and memory and stuff. See, it's a single CPU system because it's a VM, and that's all I gave it. The actual physical CPU is an i7-9700K with a bunch of cores, but only one core for this VM. You see, it's got about 8 gigs of memory, 512 megs of swap space. It's not using any swap space right now. And great to see, we're only using 54 megs of that of memory, which is pretty nice. To me, I guess I'm getting a little bit old, but I remember the days of being able to, of running a system on only a GUI-based system on only 64 megs of RAM, which was a little bit slow, but if you had 128 megs of RAM, that was completely acceptable. Way back a long time ago. But yeah, this system is only using 54 megs on the. I mean, we're not using it. There's no GUI or anything, but yeah, I mean, when you run like KDE or GNOME or something, it's easy to get up to like a gig of memory used. I'd actually be curious to see how much memory if you just run X Windows without any desktop environment, how much RAM it would use. But yeah, looks like we're only using 54 megs of RAM. We have like 3.7 gigs free. nothing shared. We're doing a little bit of buffering and caching, 63 megs. So, yeah, let's see. Yeah, that's pretty much it in terms of RAM. See, the system has been up for 3 minutes. Really, really low load average. Here's the mounted disks. You're going to see there's like some temporary file systems. You can see our dev SDA. That's our root file system mounted on root. And that's pretty much the only real file system that you see there. The other one is the dev file system run and some other temp file systems. And there's our file system table again. You can see in our Etsy issue file that we are running Arch Linux. And we did want to verify the time zone. I really did want to check that. So time date CTL status just to see. I want to see if that carried over. And yeah, looks like we're in. So after we had set the time zone during the installation, we saw that this command told us that we were still in UTC and it didn't know what our actual time zone. So after rebooting, as I expected, it does show our time zone is in New York. And yeah, if you look at local time, it's showing us the local time, which is yeah, almost 1 a.m. And in the UK, it's almost 6 a.m. Interesting thing, it's telling me NTP service is inactive. So, yeah, setting that up during install didn't help at all. And we're going to need to be root to do that. So, no sudoers. If you want to be root, you can just su to root. And there we go. So NTP active. I want to reboot this and see if that still stays like that. I know this is probably not what people want to watch me do during a tutorial on how to install Arch Linux, but I just want to say that I feel like this is a good demo. And it boots pretty fast, so it doesn't matter. And there we go. NTP is active. All right. So I guess that's a post-boot step that actually belongs in the install doc, not as a separate document or separate tutorial, but a good and important post-boot step. And I believe that's pretty much it. We've got Arch Linux installed. So yeah, this, as you can see, it's just a text-based system. it's a great start. If you wanted to run a server, you want to look into maybe like hardening the system, securing things, installing whatever services you want. If you want to run a web server or whatever you want to run, if you're going to use this as a desktop system, you might want to think about installing installing things like X Windows or GNOME, KDE, XFCE, or whatever window manager you like. I generally go for something lighter, but that's something for another day. I hope you found this tutorial useful. If you're still watching at this point, feel free, and if you found this useful, feel free to definitely like the video and subscribe to my channel for more great tutorials like this. And also, if you found the tutorial useful, just give me a nice thumbs up